Hello. I'm Gwen Katz, and I design mostly deduction puzzle games. Some of my games that you might have checked out if you like that type of game are Seradia, my game told through an art history exhibit in a museum, and Deductopia, which is a small little cute deduction puzzle game. But one of the other hats I wear when I'm not doing puzzles is curriculum designer. Um, and as I've done that, I've noticed a lot of the similarities between what we do when we're crafting good curriculum and what we do when we're crafting good puzzles. And the reason I think this is important is because puzzle design, we don't have a huge amount. Luckily, we were able to hear from a wonderful talk earlier about people who were doing research into learning and how the brain learns doing puzzles, but we don't have like a deep backlog of research on that. As it applies to video games and puzzles, we do have a very large, decades-large corpus of research on how learning affects the brain in an educational context. And those are things we can take with us into our game design. First of all, I want to ask you, and you can reply in the YouTube chat, what are the most important skills that every job asks, for every job wants you to have? So anyone got suggestions? What are things that like every employer is gonna ask you to have, no matter what your job is? Communication, absolutely. Communication. So teamwork, absolutely. Yeah, so oral communication, written communication, time management, yep. So you want to be able to manage time, you want to be able to manage supplies, be able to manage whatever you're working with. Multitasking, yeah, I tend to put that under management. Willingness to take a task to completion, yeah, that's very important. That's not specifically on my list, but that's team player, obedience. Team player, yeah, the teamwork's still very important. Passion or ambition, yeah, they always ask for like, yeah, willingness to not, yeah. Some of these are slightly cursed, but true. Yeah, ability to do unpaid overtime, yeah. We're working from an optimistic idea of what a job is here, yeah. So a few others I'm thinking of that nobody's mentioned yet. Anyone want to have a guess at some of these top ones that are kind of the most important ones? Creativity, yeah. Creativity I associate a lot with problem solving, right? When you're given tasks to solve, you got to think of yeah, I think of stability, punctuality. I think of that with like time management, yeah, and like resource management, the ability to be where you have things planned out so that you are where you need to be when you need to be. Yeah, I think of creativity as relating to problem solving. Cleanliness, I've definitely been at some workplaces where some people, I wish they'd rated that higher. Yeah, so a couple more here. We're not getting to some of the ones that actually are the most key to us here. So a couple other ones we have here that are really important are information processing. So, any job you have, they're going to give you instructions. They might be written, they might be verbal, and you need to be able to think about those instructions and how to implement them and how to do, as well as information in the forms of, charts and graphs and data and all the stuff we work with every day. Critical thinking, another crucially important one. And then the last one here is self-assessment, the ability to know, am I doing a good job at what I'm trying to do? And so you think of these a lot if you have a job like, say, you're a scientist. It's like obvious how you would use all these, but these really apply to all jobs. Even say you're like an electrician, right? you still are working with a team. You still need to have communication skills, communicate with your boss, communicate with your client. You're still going to have to manage your time. You're going to have to manage your resource. You're going to have to do problem solving if it's things like the wiring is funny in this house, and it's unclear how I'm going to get to the wiring to this outlet that's in a weird place, or things like that. So these are universally applicable skills. Now, of course, they're also skills we use a lot in games. So tell me in the chat, say you're playing Myst. What are some of these skills that we might use if you're playing Myst? What do you think? Like, if we go down the list, do you think we're using, yeah, problem solving? Absolutely, yeah. So what does this device do? I've got these weird gears, and when I rotate them, they do something, but it's not clear how that's helpful. Critical thinking, absolutely. Myst is all about critical thinking. Yeah, and information, yeah. So here's this, weird set of numbers that are written on the wall. What does this mean? Navigation, oh my gosh, I get lost so much. Yeah, problem solving is very important. Yeah, I constantly get lost in puzzle game, in any game with navigation anywhere. Yeah. I employ the skill of awake at 4 a.m. staring at the same thing, trying to figure it out. Yeah, that's me. Universal Myst experience there. Although also a good workplace skill for a lot of problems you face. Yeah, so some of those are really obvious with a game like Myst, but really all games use skills in this skill set. Like, say you're playing Overwatch, right? Okay, which of these skills are you still using these skills in Overwatch? What skills would be you using then? Yeah, teamwork. Yeah, obviously crucially important in a game like that. Teamwork probably the most important of those. How about communication? We're definitely going to use that a ton in a team-based game. You're still going to be doing things like problem solving and critical thinking. It might not be as overt, but you're going to be thinking about things like the enemy team has these guys on it, so what moves should I be using that are going to be the most effective, and how should I approach it? You're doing it all very quickly, but that's all still that kind of problem solving. And then both these games are going to be using self-assessment, because you're using self-assessment to gauge, am I good at this or not? Am I doing good? Do I need to change my approach? Yeah. So information processing, yeah. When you're looking at, all games like this will have a lot of visual signaling of things like, is their attack charge, or things like that, and that's all things you're processing visually, but you're turning it into information you can use to affect your gameplay. Those are all skills we use a lot in games, and those are all skills we use a lot in curriculum, both because they are useful skills to have that we want to teach kids and adults, so you can use them in your daily life, but also so that you can learn better, because these are also skills you apply to the learning process. And the more you engage these skills, the better you're going to learn, which means the more you engage these skills also, the better time you're going to have doing a puzzle game, and the better time your players are going to have. And we can make better use of this by understanding how the brain processes information. So sort of a vanilla model of how the brain processes information is going to be like, you have on the one side, you have your input, that's events, observations, instructions, stuff like that. And on the other side, you have your memory. And the stuff goes from the input into the memory, and then it's there. Except, as neuroscience has taught us, as research into learning has taught us, this is not how it actually works. It's not how the brain works. So a more accurate way of how the brain works is, this is hard with our lag here, is that input comes in, it comes in and it hits a perception filter, and the perception filter is gonna affect what we decide to process as important, and most stuff gets discarded, and then a small amount of stuff gets moved to our working memory, which is just temporary storage, and from there, it gets held for a short period of time, and if you repeat the information within about 5 or 10 minutes, then it gets moved to your long-term memory. Otherwise, it gets discarded. And then once it's in your long-term memory, it becomes a loop where the stuff in your long-term memory will form your previous knowledge, your corpus of knowledge, biases, and misconceptions. And those are going to feed back into your perception filter and influence how you process information later on. So let's break this down, these individual steps. Let's break down how they influence us when we're playing a game. So first, let's look at that perception filter. This is super, super important. This is what influences just what we take as important in a game, right? Like in any game, there are interactables and there are non-interactables, and there are clues and there are non-clues. And so, for instance, our perception filter tells us if a ledge is painted yellow, I can climb on it, and if it's not painted yellow, I can ignore it. So we just know not to like try to climb up random other bits of that rock face. But that can also be misinformation. So you want to, as a game designer, be really clear about overcoming the perceptual filter and making sure that everything is important is communicated. And then once stuff makes it through the perceptual filter and is in our working memory, that stuff is held kind of temporarily, and sometimes that's what we want. Every day we're flooded with like bits of information, like what's my order number at this restaurant, right? And you need to know that for a couple of minutes, and then you just forget about it, and it's fine. You don't want that clogging up your long-term memory. And sometimes in games, that's what we want too. Say, like, what's the combination to this locker? And it's going to be written on a piece of paper somewhere, and I just need to remember it long enough to get from the piece of paper to the locker and enter it in, and then I forget about it, and it's fine. But more often, we want to have players remember stuff for a longer time. Like if we're trying to teach them rules to a puzzle, we want them to internalize those and remember them for the duration of the game. And that's harder. And the key thing there is repetition. So the wrong thing to do is just tell them at once, and then it comes up when it comes up, you know, like in Psychonauts, for example, in the basic braining, there's a bit where they tell you that you can drop down on a ledge and inch along a ledge. And that comes up once, like 3/4 of the way through the game. And I'm confident, you know, 90% of players have by that time forgotten that you could do that, because they just told you that and then never reminded you of that. So the correct way to move stuff into long-term memory, the correct way to tutorialize is not to just give you a bunch of information. It's to teach you something and then make you do it, and then a few minutes later make you do it again, and ideally do that several times. So, you know, most side scrollers, for instance, you know, they'll tell you like, yeah, press up to jump, and then there will be a place where you have to jump. And then there will be a place where you have to jump a few minutes later, and you'll practice using that skill, and that's going to put it in your long-term memory, and that's going to mean that you remember that instruction. Yeah, and so once stuff is in our long-term memory, yeah, we can, understanding that can tell us how tutorials do and don't work well. Like, for instance, the reason why board games are so hard and boring to learn is just that, by definition, you have to just give the player 100% of the instructions all up front, and you have to read them all before you play any of the game. right? So you don't get a chance to apply the stuff you learn. And it's just moving into your working memory and then getting forgotten. And then when you actually get to the juncture of the game where you needed to do that, you've forgotten about it. And so that gives us an idea about how we can do better at making a tutorial. Is, a lot of games have interactive tutorials where it'll be just a little mini tutorial level where it will tell you, drop this card onto this enemy to deal 3 damage, and you'll do that, and you'll play through a little level, and then you'll and then you know how to play the game. And since it's reinforced all that stuff through doing it and repeating it, that stuff you're going to actually go into the first level of the game actually remembering what the instructions are. Now, then finally, we're going to look at those the stuff in our long-term memory. Every game we play is going to influence how we approach the next game, as well as non-game information sources. So whatever happens in the previous games we've played is going to become data for us about what should we expect from the next game we play. And that can be a good thing, or that can be a bad thing. Like, for instance, one of the reasons Blueprints is so incredibly difficult is that every other adventure puzzle type game we've played has taught us that if something is interactable, it has like a little interactable icon. And even if you don't have like the right item to use on it, it'll jiggle or something when you click on it to tell you that you can do something here. Blueprints broke with that. It has interactables that if you don't have the right item to use there, give you no signal that you can interact with that at all. And that, you can look at that as a positive or a negative, kind of depending on, I do think it's a very deliberate choice in that game. It's certainly a choice that vastly increases the difficulty. So that's something you want to be cognizant of. If you make a choice like that, that goes counter to the perceptual filter, it's going to be really, really complicated for your players. Now, a phrase we talk about a lot in curriculum design is the aha moment, which you might notice is the same phrase we talk a lot about in puzzle design, right? In both fields, it's really important to try to lead your player or your student. If you can lead them, instead of just telling them information, you can lead them to figuring out information on their own. That's way more effective at making it stick in their brain. It's both fun and makes the experience better, and it also makes them do better at the experience. It's an incredibly effective way to get information, to get cemented into your long-term memory. So for example, in a game like The Witness, they teach us that anything that's this shape is a line puzzle. And there's this incredibly strong aha moment, sorry, spoilers for The Witness, where you realize that that's not just true of things that are on like a puzzle grid, it's true of anything anywhere in the world is a solvable puzzle. But that's the big aha moment. But the game is also full of like a long series of small aha moments that are just straight from the beginning, figuring out what the objective is, figuring out what every single one of these cryptic symbols means. These are all small aha moments, and those both make it more fun, and they also make you better at learning. So one thing I think The Witness was very difficult in many ways, but one thing I don't think most people encountered was just forgetting what the symbols did, right? Because it's using all of these tricks, it's using the repetition, and it's using the aha moment to make sure they really get firmly in your brain, and once you learn them, you really remember them. So anyway, to talk about curriculum design and how we use this, the specific curriculum program I am part of is called the POGLE Project, and POGLE stands for Process-Oriented Guided Inquiry Learning. These slides I mostly stole from them, and they told me I could use them on the grounds that I plugged their project, so I am. So that's kind of a education-ese name, but basically what it means is it's making use of those process skills that we talked about at the beginning, and also deductive and inductive reasoning, inquiry-based reasoning to lead students to answers and create those aha moments in order to create better learning. Now, can that also create more fun learning? Yes. But the main reason we're doing it in this context is just because students learn better. So the technique we use in POGIL is called the EIA cycle. So the first stage of that cycle is explore. And so you begin your curriculum by you begin with a model that's got usually images, and you begin with a few questions that just ask the students, just look at the model, just, see what's going on there. Then you move on to questions where they do concept invention, where you tell them, okay, so based on this model, what can we figure out is true, and how can we generalize that? So what's the rule going on here? And finally, apply, where we figured out the rule, and now we give them some examples about, so what would happen in this case, right? So this moves from, you might notice this uses both types of logic. It begins with inductive logic. It begins with, here's a bunch of examples of stuff, and you're figuring out what the generalizing the rule is. And the deductive logic is, I now know the rule, here's a new thing, how does it apply in this case? So looking at a specific curriculum exercise, this is one I worked on in my book of principles of art. In this case, our figure is saturated and desaturated colors. So we're just giving an example of here what the saturated colors look like, and here what the desaturated colors look like. So we begin then with our explore questions, which are really obvious. They're just asking us, they're just asking students, look at the model, see what's going on there. Sometimes it'll be things like circle something. And then we move on to the invent questions, where we actually ask them, okay, what is a saturated color? What is a desaturated color based on what you see on this wheel? And then finally, we move on to the apply questions, where in my case, it'll be something like, we'll show them a new artwork and we'll say, are these colors mostly saturated or are they mostly desaturated? Now, we can use the same exact same cycle to create interesting puzzles. And what's interesting is a lot of games with really good puzzle solving are already using a cycle that's a lot like this, just intuitively, just because it makes a good puzzle solving experience. So for example, take Case of the Golden Idol. The model is the whole room, right? So the model is, you've got images, you've got text, you're looking at this scene, and you're working out what's happening in that scene. Come on, lag. Okay, pop up here in a second. And so when you initially look at the model, the first thing you do in Case of the Golden Idol, right, is you click on everything and you gather all the words. And this is our explore phase, right? Right now, we're not trying to solve the problem yet. We're just being encouraged to engage with the model, to look at everything and click on everything, open every container, look at everyone's dialogue, find the contents of everyone's pocket, and that makes sure we didn't miss anything. Now we move to invent, and that's these little side puzzles, right? So in this room, there's the math puzzle where we go like, oh, there's a law against this, and you get punished with this many demerits. And finally, once we've done all of those, then we've got our main puzzle. And the main puzzle is, of course, usually really cryptic when you first open the room. You look at it and you go like, sometimes they have a lot of blanks and you go, I don't even understand how that's a sentence. But through exploring the scene, through the concept invention of just understanding the underlying principles that are at work in this scene, once you've done all of those, then you have all the data to apply in this final puzzle to say, okay, what happened here? So that's the sort of thing that we can, if you have a puzzle that's maybe not working as well as you wanted now, this kind of arms us with a lot of ideas for how we can improve it. Like a lot of my games have struggled with the explore phase. A lot of my games have struggled with like people just didn't open everything and look at everything. People didn't turn all the pages in the books, you know. And what you discover doesn't work is like put a big highlight on it that says, that flashes, that says open this. That really works surprisingly poorly. So you want to think about what in your game can be more of an explore phase. So like in a game like The Witness, the reason they send you wandering all over the island to look for where's the next little puzzle grid, that's also exposing you to the environment. So that's part of the explore phase is showing you all the environment, and you'll start noticing, oh, there are these things that look like puzzles, and that equips you to, when you discover that those environmental puzzles are part of the game, you're already familiar with the environment and you have a sense of what you're going to have to do now. So that is basically how I've learned to use curriculum design to influence puzzle design that equips us with. So you can think about this when you're designing your puzzles. You can think about the perceptual filter. How can I make people better at looking at the important information and dividing what's important or what's not? Or if you want, you can, invert that and go, I want to make something trickier by hiding it from the perception filter. You can think about what you're trying to move into short-term memory and what you're trying to move into long-term memory, and use that to reinforce the important information and minimize the unimportant information that's just things like, the code to a door, and how you are creating or altering their previous preconceptions and biases to make them more effective at this game and at future games, maybe of yours that you've played. We can think about the process skills. We can think about how our game is engaging things like information processing and self-assessment and problem solving. And we can think about this EIA cycle. We can think about how are we guiding the player through a puzzle, even if it's a very good puzzle, a huge amount of whether they succeed or fail or whether they have a good time is how do we guide them through? Where do we start them? How do we move them through inventing the key principles of this puzzle, and then how do we get them to apply it to solve the puzzle? So that is my talk, and does anyone have any questions?
Thank you so much. I love that. I feel like I think I was one of the people who played Seradia and didn't flip over a page and therefore didn't discover something I needed.
I desperately feel like I should have patched Seradia before giving this talk, because it was one of those things where when I was thinking about this connection, it immediately pops out at me like, I'm not doing a good job at every aspect of this. Right? So yeah, like what way you can have, like, some of the games of this sort will have like a counter of like how many of the clues have you found, how many things are left to discover, and that kind of thing can also work for the explore phase to kind of engage you to be like, you should just be looking around right now. You don't need to be solving stuff yet. Right now, just poke around where you haven't poked around as much as you need to.
Absolutely, and it's hard as a game developer to make sure you're doing all of these things perfectly. So
yeah. Well, that's one thing you can look at curriculum design. If it's something you want more, you want to think more about, you can look at exercises like this, like the POGL exercises, and you can look at how they physically do that. Like, what do their models look like? What do their questions look like? And then think about, like, you don't usually in a game just give people quiz questions like, what's the name of room 1 of this puzzle? But you can think about sort of ways to use the same kind of guidance to, even if it's not as explicit.
So Celia had a question in the chat, which is related to this topic. You mentioned the explore phase not working well in some of your games, and what didn't work. Curious if you have an example of what approach did help with the explore phase.
Yeah. So, yeah, as I mentioned, that is a ongoing problem that I really need to patch in my games. Um, yeah, so the things that didn't help, yeah, like I'm probably just going to put in like a pop-up that like when you go to the solve page or when you try to click on a hint, we'll straight up just have a pop-up that says there are more things to look at. But I think some of the effective ones, I think really Golden Idol doing the clicking on the names to collect them is an incredibly good incentive. That just getting people, and that can be things like also like if you have collectible hats or something and you have an incentive to find all the hats or anything like that, is really good at just making people look at all the little nooks and crannies of your game. And when they do that, they're also seeing all your clues and things. You're remembering this room is here. You can open this container and all that stuff that they need to do to actually solve the problems. And if you don't do enough explore, they just won't find that stuff and they'll go straight to the problems. And they'll have the problem of being like, how could I possibly solve this? And once they get to the invent stage, they often won't go back to explore once you think you have enough information. It's hard to get people to go back to, no, I need to be looking around more.
Perfect, thank you. Another question just came up in chat about Metroidvania as a genre. However, we don't really have time, so would it be good? Would it be okay for that chat to be taken to Discord? You're there, Gwen.
Yeah, of course. Yeah, I'm on the Discord, and I'll be happy to discuss some more. Yeah, I might post some examples of like if people are interested of exercises and things to kind of show you more how this works.
Perfect. I've also been fascinated in this. Like, I've been wanting to do a talk at some point about the puzzle solving process, and but it's basically this exact same diagram. You're coming at it from a different angle.
Well, this diagram is really strongly rooted just in neuroscience, right? This is just how your brain processes, and so even unrelated programs and stuff will kind of independently invent really similar diagrams because that's just how you process something when you're looking at it.
Exactly. Yeah, so thank you so much. We'll switch over to the next talk now. So yeah, thanks for joining us, Gwen.
Yep. Goodbye.